Hello everyone. I welcome you all for the second session of Unsymmetrical faults with respect to synchronous generator terminals. Let us see the problem. A 3-phase 50 MVA 11 kV star connected neutral solidly grounded generator operating on no load at rated voltage give the following fault current for the specified fault. So they have provided with the different fault conditions the fault current value. Now what they are asking us to find, determine the three sequence reactances in ohms as well as the per unit quantities. This is the another type of problem which we can expect with respect to the unsymmetrical fault. Last problem we have seen, they have given us the sequence reactances, they have asked us to find the fault current. Now they have given us the fault current, they are asking us to find out the sequence reactance. Given values, if you see, we know the MVA base value 50 and we know the kV base value as 11 kV and the fault currents has given in terms of the amperes. So obviously whatever we are going to find the reactance values, those will result in terms of the ohms because all the values we know in terms of the actual units. So definitely the reactance will result into the ohms. But he is asking, find out the sequence reactances in ohms as well as the per unit quantity. What is the relation between the per unit quantity and the actual value? We know the per unit quantity is equal to actual value by base value. So to find out the per unit quantity, actual values anyway, if you substitute in the equation, we will get directly the reactance values in terms of ohms. Those reactance values we need to convert into per unit by using this formula. So for that we need to know the value of X base. So before starting the problem, first let us find the base value of the reactance. So we know MVA base value as a 50 MVA and kV base value as 11 kV, and we know the relation, the impedance S is equal to V square by Z, or if they have given instead of Z only the reactance, you can write this as a V square by X. Then the X base value is equal to V base value square by S base value. So that is nothing but voltage, they have given it as a kV base value. You can write that as a kV base square divided by S value is nothing but MVA, that is equal to MVA base value. So by using this formula you can find out kV base value square. So 11 kV square, 10 cube square will become 10 power 6 in numerator, and in the denominator also we will have 50 into 10 power 6 because it is MVA. Both will get cancelled. This is equal to 2.42 ohms. That's it. One time if you find the X base value, that is common for all the values. So we no need to find again and again. Just we have to divide this value with respect to the actual value. Then we will get the per unit value. Now let us start the actual problem. They have given us a 3-phase fault as a 2000 amperes. Now 3-phase fault. What will be the circuit? 3-phase fault is a symmetrical fault. We know this is the equivalent circuit for the 3-phase fault. 3-phase fault will have only the positive sequence component. We won't be having any negative and the zero sequence. Why? Because even though it is a fault, the system will be perfectly under balanced and symmetrical condition. So now this is the IA1 current. We know the fault current is nothing but the current flowing through the circuit, which is equal to IA1, that is equal to EA divided by Z1. Voltage value is equal to 11 kV. So that is 11,000 divided by root 3 with respect to the phase voltage, because the impedances will be provided with respect to the phase quantities. So we cannot take the voltage as a line value. So we need to convert the given voltage with respect to the phase quantities. So here the resistance will be 0. You can represent the same Z1 as a X1. So this will be X1. The fault current, what is the fault current given? Fault current is 2000 amperes. That's it. Then the X1 in terms of ohms is equal to 11,000 divided by root 3 into 2000. So if you simplify this, we will get 3.175 ohms as a positive sequence reactance. But we want the positive sequence reactance in per unit also. Per unit value is equal to actual value. Actual value is 3.175 divided by the base value. Base value just now we have determined, that is 2.42 ohms. We will get 1.31 per unit. That's it. So positive sequence component we got. Now we need to find out the negative and the zero sequence component. Next we will see the LL fault. Line to line fault current is given as a 1800 amperes. So fault current is given as 1800 amperes. Now let us see which sequence reactance we will get from this fault. We know the line to line fault. They have not given the ZF value. If they have not given the ZF value, so the positive sequence network and the negative sequence network both will be connected in parallel to each other. So this is current IA1 and this is current IA2 and this is Z1 impedance, or you can say X1. So this you can replace by X2 and this is EA value. Now what is the formula for this? The current IA1. We know that the current IA1 is equal to minus IA2, which is equal to total voltage EA divided by X1 plus X2. So EA value is 11,000 divided by root 3. X1 plus X2. X1 just now we have determined. So which one we have to use? We know both the values. We know the per unit value and we know the ohms also. Since we are considering all the remaining values in terms of the actual units, we need to consider this X1 also in terms of ohms only. So not in terms of per unit. 1800 divided by. So just now we got X1 ohm is equal to 3.175. So that is 3.175 plus X2. So if you simplify this, we will get X2 value as 11,000 divided by root 3 into 1800. This complete value minus 3.175, which will give us 2.936 ohms. Therefore, the per unit value of X2 is equal to actual value. Actual value is 2.936 divided by base value is 2.42. That is equal to 1.213 per unit. Now we got the positive as well as the negative sequence reactance. Now we need to find out only the zero sequence reactance. So for that we will take this LG fault condition. The line to ground fault as given as a 2200 amperes. So line to ground fault, the fault current is given as 2200 ampere. If you remember the network very well, directly you can write the equation for fault current. What is the fault current equation? 3 times of IA naught. What is the IA naught current? 3 times of EA divided by Z1 plus Z2 plus Z naught, because we don't have any fault impedance. We know that in single line to ground fault, the sequence networks will be connected in series fashion. This is the positive sequence impedance, negative sequence and the zero sequence impedance. We know that total current IA1 is equal to IA2, that is equal to IA naught. So you can write IA naught as a total voltage by total impedance. So what is the fault current? Fault current is given as a 2200 amperes, that is equal to 3 times of EA value is 11,000 by root 3 divided by Z1 plus Z2 plus Z0 value. What is the Z1 value? X1 value is 3.175 ohms. So here in place of Z1, X1 is given, that is 3.175. Don't confuse the Z1 only. I am calling it as a reactance because the resistance is negligible here, and the X2 value is 2.936 plus X0 value. So if we simplify this, we will get X0 value as 2.549 ohms. Therefore, X0 per unit is equal to actual value by base value 2.549 by 2.42. That is equal to 1.0533 per unit. This is how we have to find the sequence reactances if they have provided us the fault current for different types of fault. I hope it is clear. Still, if you have any doubt, please let me know. Thank you.